Let's start. Okay, so here we are. Just follow along and write this down as I'm adding, right? You want to make sure you have this as part of your notes. In fact, I will probably go back in the booklet and tell you to go to page 12 to see more examples, all right? Okay, so what type of triangle has two equal sides and all angles less than 90? That would be an acute isosceles, right? What if I told you that there's a triangle with two angles that are the same and they're all less than 90? You'd still say acute isosceles, right? Okay. Sometimes if you overthink it, you're actually going to lose marks, right? Like sometimes it's just like, okay, right? Is triangle A congruent to triangle B? So it's just one letter, right? Congruent would means what? Are they equal to each other? Are they the same? So this is the symbol for congruency. It's an equal sign with a little squiggly on the top. That's congruent. You're saying they're the same in every way, okay? So if you think about it, right, this triangle has two sides that are the same here, right? And so the triangle A is an acute isosceles because it has two sides that are the same. Triangle B is also an acute isosceles because the 1.3 is also here, right? So this triangle has two sides that are the same. And we know it's acute, you just look at the diagram, right? It's obvious that all the angles are less than 90. Explain using your reasoning. I think when you ever show your work, your reasoning or whatever, just if there needs to be something added in terms of angles or whatever, if you need to subtract it from 180 to fill in more, then that's what I mean by that. So that would be it. And triangle A is congruent to triangle B. Okay. Both have same side lengths. And therefore, all the angles are going to be the same as well. One is just flipped upside down. Right? Let me just try to zoom in a little bit. Both have same side lengths. Let's add that here. And therefore, all angles are equal as well. This one is deceiving. All angles, like their angles, are equal. Okay, I'm not saying that all the angles within each triangle. It's just like if you compare each triangle, you have the same angles. Okay. Three. What type of triangle is XYZ? So X, Y, Z, you're using the big one, right? Like, let me use a highlighter here. This triangle here is talking about this one here, right? That's the one we're talking about. And you want to explain your reasoning using XYW, triangle XYW. So just follow it, X, Y, W. So they want to use this one here, right? This is, let's put 1, like triangle 1, and this other one is triangle 2. And they should have given you a 90 here. That should have been there for you to get that right. And so we can combine these two and say that 60 and 30 is 90 centimeters, right? So all three sides are different. All sides are different. So it's going to be a scalene. All sides are different, scalene, right? And what about the angles though? Is there a possibility for one of the angles to be obtuse? Is there a possible scenario where angle Y is that obtuse? You have to check. Angle Y is the greatest angle that you could possibly have, correct? Because it has the longest side across from it. Just think about it that way. So Y is the one that I'm questioning here. So angle Y, so we got to go cosine of Y. Why am I using cosine law? Side, 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 right? Side, side, side. So cosine of Y is the side that's across from that angle, which is 90. I'm going to square that. Then I'm going to go 40 squared plus 20 squared. Just write this down, right? And that is minus. That has to be minus. Then follow, right? 2 times 40 times 20. We're going to figure out what both of them are. I don't have the key in front of me. So this is going to actually be, there are going to be no decimals here, so that's nice at the beginning at least. So watch this. True or false? If I get a negative here, it's game over. We know it's obtuse, right? Okay. Do I get a negative? Yeah. You can stop there because I'm not asking you to solve the angle. Does that make sense what I just did there? Y is the one I questioned because that one could have been obtuse. I check, I plug that in, that's done, right? So because of this, it's going to be obtuse. So if sometimes you have to check, right? Therefore, triangle X, Y, Z is going to be an obtuse scalene. And you're just like, right? You just brought in trig, Mr. Dirksen? That's not fair, right? Yeah. You can do scalene obtuse scalene, doesn't matter. Yeah, doesn't matter to me at all, as long as they show up. Yeah. Sorry? Up here? Because of, I would say because of the diagram, the way it's drawn. Okay. Okay. Do you want to check? Let's check. Okay. It's a very valid question, and I probably jumped the gun on that one. On a test, I will probably be very specific. Like, I'll ask you, hey, solve this first and then check, right? So let's try that real quick here. This would be 1.3 squared plus 1.3 squared, right? Right, because it's the one across the 2.2 that I'm interested in, minus 2.2 squared. Ooh. I got busted here. I need to change those numbers. Let's make that, because otherwise we have to erase everything. Let's make this, I will change that into like a 1.2 or something. Because if I make that 1.2 here at the end, the subtracting, then we're safe, right? So let's make this a 1.2. Good catch. Good catch. I just got schooled right on. I love that. I love when that happens, actually. So bring it on. Okay. So nothing happened there. Okay, it was always 1.2. Nothing happened. Good. All right, let's keep going. Next time, just go out those doors. Right? All right. So this one, what would this angle be right here? This one gives it away. Use a highlighter here. You see the straight line here? It's 180 along that line. So this must be 60, right? Because of the straight line here, this must be 60. Then this is 60 and this is 60, so I can easily find that third angle. You already know what that is, don't you? Sorry, 180 minus 60 minus 60. So that is equal to 60 also. You could have already concluded that after knowing that both of them are 60. So we know this one is acute equilateral. Acute equilateral. Just equilateral is fine because you can't draw an obtuse equilateral, right? They're always going to be 60. So it all started with bringing in, watch this, I will write this word down, supplementary angles, right, are equal to 180 along this line, along that straight line there. So if something is outside the shape, bring it in by just subtracting it from 180, okay? And then one more, just like that, I can guarantee you one of these is going to be on the test. One of these where you have to bring it in. Because the supplementary we've talked about in trig so far. So this one here is 180 minus 138. Okay, so that is 42. So you bring that in, you show the work right here. This one is also 42 because it's the same angle outside. So this is 42 as well. 42 there, 42 there. What kind of triangle is it already for sure because of this? Cross, right? Go across. This one is the same as that one, right? If the angles are the same, then the sides across them are also the same. I can easily find the third one. 180 minus 42 minus 42. That's 84, right? So that's 96. Oops, what's 96? Obtuse, right? So because of this 96 here, and it's like a puzzle, start somewhere, figure out information, fill it in. Because of this, it's obtuse. So I will say because of this, it's obtuse. Because of these two angles, it is isosceles. Okay. So because of these two angles, we know it's isosceles. And that third one we found gave it away that it's obtuse. If that had been 88, it would have been acute, right? 89, acute. 89.5, acute, right? Yeah. You're right, you only get half marks if you just get one of them. Yeah. Yeah. And in this case, there was a significant amount of work you needed to do to come up with this. So this would have been a 3-mark question, most likely. Yeah. Yeah. So, okay, this is what I want you to know. Maybe have this on your study sheet. This one, right? If this is 120, then this is 60. These are supplementary, right? Supplementary angles add up to 180. Sorry, I'm going to zoom into that. This is one property you want to use in trig all the time. Okay, and then you have sum of angles in a triangle add up to 180. You want to use that one as well. These two are going to be gold for you, right? If you know those two properties, you can do a lot. And of course the isosceles, right? Oh, the two sides are the same. If one of the angles are given, they actually are giving you two angles, right? Okay. So now we're going to say back to page 187 and the notes, right? We're going to go back to 187 and notes. So you know if you go here, so now you grab your notes. Yeah, go run. Because I'm going to start quadrilateral soon. That's the next part. I guarantee you, if you sit down, right, if you sit down and work through some of these questions, you should be able to get it after a while, right? But make sure you write down the notes, make sure you do all of that, and I will help you with the rest, okay? So 187 in our book, notebook, right, this one, looks like that. At the top of this, I will say this, see page 12 in workbook, right? So you know that when you get to this page, for examples, right? For more examples. So that I don't like to just have stuff all over the place. I want to know when I go through my notes, where is everything? What's the progression, right? So page 187 in your notes, you write this down at the top. Okay? All right. We'll do a couple more and then I move on to quadrilateral, so have your notes ready. Classify each triangle by angle measure and side length. Give reasons for your classification. This is show work. Okay? That's what that means, give reasons for it. This triangle, you think it's a 90, right? You might think it's a 90. Well, we have to check, right? Sum of a triangle is equal to 180. That's the one I'm using here. So 180. Let's call this angle C here. Angle C is 180 minus 50 minus 47. And that gives you angle C of, it's really 180 minus 97, really. And so that is 83. Angle C here, if you don't put that angle symbol in front, I'm okay with it, right? Angle C is 83, you just found that. So what kind of a triangle is it when it comes to angles? It's acute, right? What about when it comes to, yeah, Lawrence? Question? Okay. What about when it comes to side lengths? Mr. Dirksen, there are no sides. But then you have to remember, if all three angles are different, then all three sides are different. So let's do that. This is different than this, which is different than this, right? We're guaranteed that because so acute scalene. I hope you're grasping it by now, what's happening here. I'm using angles and sides, vice versa, right, to come up with conclusions, right? So acute, because, write this down, all angles less than 90 degrees. That's why that's the conclusion that we came with there. Scalene, this seems contradictory, but all angles are different. And you know what in math, therefore is like this. Therefore is like a triangle, 3 dots like that. Therefore, all sides are different. Let me zoom into that so you can copy that. Okay. All sides. This is the observation I made, and I concluded this. Therefore, I was able to say that this is scalene when it comes to side length. This part, no. I would just want you to show me how you got that 83. That I would like to see there. That explains, yeah. Unless, let's say I give you like a little box where I say, explain with your words how you concluded that. Like if I do something like that, I would like you to actually write how you came up with it. But most of the time it's just do a little bit of math and then name it, right? And this is not going to be everything. Like we're actually going to move a little bit away from this today. Anyways, next here, look at this triangle. Let's give it a name, XYZ. So this is triangle XYZ, okay? If there are no letters, put some letters there. And if you're falling asleep, wake up. Okay. This is very important to me. The markings, watch out. If this side is the same as this, then they both have to have the same angle across from them. Okay, it's the across that you need to be careful with. So the markings gave away the fact that this 15 had to be there. So you know two angles already. Even in trig, guys, if you know two angles, find the third one. Okay. So angle X, I'm going to close this off here. I don't want to mix them up. Angle X is 180 minus 15 minus 15. So that's 30, right? So what we end up with 150. Let me move that up. The minute you have an angle bigger than 90, this is now obtuse in terms of the angles, and in terms of sides, we know we can just look at the sides, the markings. It's isosceles. I think you're getting it by now. I hope so. And put an arrow like this, obtuse because of that. Two reasons you could have said this is an isosceles. There are two angles that are 15, or both sides are marked. Either way, okay? So it's kind of like counterintuitive. Like how come you're using angles to name it by side length, right? And that's just it. Okay. Let's cut this off here too. Let's call this ABC. It's easy as that, right? Which two angles are the same? 5.5. This side is the same as that side, correct? Arrow, go across. This angle is going to be the same as this angle. These two are the same. This one is given. So watch what I'm going to do here. Angle, which one do you want to find? They're both the same. B or C? B. Okay. You take 180. You subtract the one you know. And then what do you do with that remainder? You split that in half. Because these two are going to, like if this had been 50, you take 180 minus 50 and split that remaining amount in the two angles that are here. So this is 120 divided by 2, which is 60. Let's do this here. If you have a highlighter, you take that 60 and you highlight that 60. Because this formula is always going to be used like that. The divided by 2 is because of, realize that I highlight a lot. Yeah. Let me just do this, okay? Otherwise, I'm going to, the 2 is because you're splitting that into 2. Go ahead, Lawrence.
I didn't really calculate it because I just knew it on my head. But can you just say that we have two equal sides and you see a 60? Can you say it's an equilateral? Well,
I would assume so. I would assume so because yeah. It would always be. I was just thinking before I respond. Yes, it's always going to be the case. I would like you to do some calculating. Good question. There was a hand up back here. Eric, hand up. It's okay. If you don't show me how you got it, just show me. You don't have to use this exact formula. You could go 180, right? Minus 60 is 120. Divided by 2 is 60. You could have done that as well. Yeah. Oh, yeah. If you use your words carefully, yeah. I did this and then that. Yeah. Yeah, I'm fine with that. All right. More questions than my 11-year-old. Dad, why is this? Why is this? Why is this? It's all good. It's good. Yeah.
So I can explain it by saying equal side equals same angle. And it's like that.
The best is to do it this way. Yeah. Because if I don't really understand exactly what you're writing, then you might be in trouble. So just show me some way, like go arrows all over the place. I love arrows. I love highlighters, right? So you know that already. So just show your work. Anyways, we're going to stop there. Oh, we're not done yet. Because everything is 60, because I just found B this way, but I know that these are the same. So now this is 60 and this is 60. All are less than 90. So this is an acute equilateral. All angles are 60, right? That's why I made that conclusion. Acute, they're always acute. Right? Yeah, I'm just going to leave it like that. Maybe a little note here. Since all angles are equal, all sides are equal.
Yeah, that's what I was trying to say.
After I made that conclusion though after doing this, right? Yeah. That's you. All right, I'm moving on. So I'm gonna skip a little bit. Skip a row. So keep going, keep going. If you go to page 190, there are two blank pages, 190 and 191. This is where you want to have, if you have a color like a red or blue, every once in a while I will actually like put in a marking that will stick out. If you have a highlighter, obviously that is also good. So go to page 190. I'm gonna start the recording